Close your eyes for a moment and imagine floating far above the Earth, where silence stretches wider than oceans and time feels slower than dreams. This is the solar system, our ancient neighborhood, turning in quiet harmony around a single golden star. Every world here has a secret, every orbit carries a story, and every faint whisper of dust is older than all of human history. Tonight, we'll wander gently among these truths, not with haste, but with wonder. We'll step into beginnings, lean into mysteries, and pause at details that feel almost too small to matter. Yet they shape everything we know. Let's allow the weight of billions of years to move lightly across our minds, as if the universe itself is telling us a bedtime story. The solar system's silent beginning. In the beginning there was no sun, no planets, no moons, only a cold cloud of gas and dust drifting in the void. From that silence, a slow swirl began, as if some unseen hand stirred a spoon inside a dark, cosmic bowl. The tiny grains pulled toward one another, colliding, sticking, growing. At first, they were nothing more than specks no larger than sand in a desert breeze. Yet in those collisions lay the seeds of everything that would come. Imagine the patience of space, millions of years when nothing much seemed to happen, yet gravity was quietly gathering, pulling, shaping. The center grew heavier and hotter, pressing itself into fire. One day, the first light broke out, and our sun was born. Around it, fragments kept circling, crashing, merging. Some grew large enough to clear paths, becoming the planets. Others remained broken, scattered like crumbs across a vast table. The silence of that early time is almost impossible to picture. No sound could carry there, only the endless ballet of dust becoming stone, stone becoming mountains, mountains becoming worlds. And yet, it was all happening at once, as if time itself wanted to build something steady. Perhaps the most striking thought is this: we are still living inside that story, still circling the same star that rose from that cloud so long ago. The sun's hidden weight that holds us all. The sun doesn't just shine, it commands. At its core, it is a giant of weight, holding 99.8% of all the mass in the solar system. Everything else, every planet, moon, comet, and drifting rock, is caught inside its invisible grip. You and I are here, breathing only because of that pull. Picture a rope tied around you, gently but firmly keeping you in place. That's what gravity is, except the rope is made of nothing we can see. Planets try to fly away, pulled outward by their own momentum, yet the sun keeps tugging them back. That balance between falling and flying is why Earth stays at just the right distance, not too far for ice, not too close for fire. The sun's hidden weight is so immense it bends space itself. Light curves near it, time ticks slower around it. If it were smaller, the solar system would unravel, planets drifting away like marbles scattered from a jar. But because it is exactly what it is, we find ourselves in a universe where life can exist. A star so ordinary among billions, and yet for us, the only one that matters. Light that takes 8 minutes to reach Earth. When sunlight touches your skin, you're feeling something that left the sun 8 minutes ago. It's a gentle delay, a reminder that we're always looking into the past. At the speed of light, 93 million miles is crossed in just under 500 seconds. That's the distance between our warmth and frozen darkness. But here's a quiet truth. The light you see doesn't begin on the surface of the sun. It starts deep in its core, where atoms collide so violently they release bursts of energy. That energy fights its way outward, bouncing, scattering, lost in a maze of solar plasma. Some scientists say a single photon can take thousands, even millions, of years to escape the sun's heart before racing toward us in minutes. Imagine that, a journey of ages ending in a heartbeat on your hand. Every sunrise, then, is more than a routine. It's an ancient traveler finally reaching its destination. The light falling across your desk or your pillow tonight could have been trapped inside the sun before humans even existed. To think of sunlight this way changes everything. It becomes not just brightness, but memory. Why the sun's heart never truly sleeps. Deep inside, the sun is alive with constant fire. Yet unlike flames on Earth, this fire doesn't burn wood or oil. It fuses atoms, hydrogen pressed so tightly it becomes helium. In that union, light and heat are born, spilling outward in every direction. This is nuclear fusion, the quiet heartbeat of a star. The sun never rests. Every second it transforms over 600 million tons of hydrogen into energy. To us it feels steady, a golden disk that rises and falls. But inside it is restless, roaring with reactions we cannot hear. Imagine standing near a furnace where silence hides behind the flames. And that's the paradox of the sun. Peaceful to our eyes, violent in its core, and yet it is this endless process that makes life possible. Without it, Earth would be a frozen stone. With it, we have oceans, forests, children laughing in playgrounds. The sun's heart may be alien, but its gift is deeply human. Its quiet promise is simple. As long as I burn, you may live. Mercury, the planet closest to the fire. If you could stand on Mercury, the sun would loom 3 times larger than it does on Earth. The heat would be unbearable during the day, enough to melt lead. And yet at night, when the planet turns away, the temperature would plunge to deadly cold, hundreds of degrees below freezing. Mercury is a world of extremes, swinging between fire and ice in silence. There is no thick atmosphere to soften the change, no blanket of air to trap warmth, no clouds to shade the ground. Just a rocky, cratered surface scarred by billions of years of impacts. It feels like a planet frozen in time, a relic of how worlds looked before life ever touched them. To walk there would be to step inside history itself. And though it is small, Mercury moves faster than any other planet, racing around the sun in just 88 Earth days. A year passes there before you could even finish one season on Earth. Imagine watching sunsets so quick, so frequent, the sky never feels settled. Mercury is restless, a planet forever running, forever close to the fire. Strange days that last longer than Mercury's years. On Mercury, a day is not what we think it is. The planet spins so slowly that one single day, from sunrise to the next sunrise, stretches across 176 Earth days. That means if you stood on Mercury to watch the sun rise, you'd wait almost half a year before you saw it rise again. But here's the strange part. Its year, the time it takes to orbit the sun, is only 88 Earth days. So Mercury's year is shorter than its day? Imagine celebrating your birthday twice before you even finish one sunrise. It bends the way we understand time itself. Days and years trade places there, blurring what we call ordinary. This odd rhythm also makes the sky appear surreal. If you were standing on Mercury at just the right point, you would see the sun rise, pause, set backward, then rise again. A dance of light that no Earth sky has ever shown. The heavens would move strangely, as if the rules of motion were rewritten there. It leaves us wondering what it would feel like to live with such a clock. To measure time not in hours or days, but in strange cycles where the sun itself hesitates, almost unsure of its own direction. That thought alone carries you deeper into the strangeness of our solar system. Venus, the planet that spins backwards. Venus is a planet of mirrors, bright and beautiful from afar, but filled with secrets the closer you look. One of its strangest truths is the way it spins. While almost every other planet rotates eastward, Venus turns the opposite way. If you could stand on its surface, the sun would rise in the west and set in the east. Why does it do this? Some believe Venus was struck long ago by a colossal impact, a crash so great it reversed its spin. Others think it slowed over time, caught in a cosmic tug-of-war between gravity and its thick atmosphere. Whatever the cause, the result is a world turned upside down. And this backward spin doesn't move quickly. A single rotation on Venus takes 243 Earth days. Strangely, that's longer than its year, which is only 225 Earth days. So if you were a traveller there, you would live through 1 year before you'd ever finish 1 full day. A puzzle that makes time itself feel heavy. Standing there would be like stepping into a dream where clocks no longer matter. The slow, reversed spin would stretch shadows endlessly, making you wonder if morning and evening even exist in the way we know them. Venus becomes not just a planet, but a riddle in motion. Clouds that rain. Metal on Venus. The surface of Venus is hidden under thick clouds, so dense they trap heat like a furnace. Temperatures soar hot enough to melt lead, and pressure crushes like the depths of an ocean trench. But it is the clouds that hold the strangest secret. Instead of water, they are filled with sulfuric acid, and high in the atmosphere, metals like lead and bismuth can condense, falling like metallic snow. Imagine looking up and seeing droplets of acid drifting through a yellow haze. Imagine mountains dusted with a glittering coat of frozen metals. It is a place where rain is not life-giving but corrosive, where every drop eats away at stone. Venus, though so close to Earth in size and structure, feels more like a warning than a sibling. It shows us what happens when heat and atmosphere spiral beyond balance. Some even call it Earth's twin gone wrong, a mirror showing a path we hope never to follow. The thought lingers, if Venus once had oceans and skies like ours, what happened to turn it into this? Was it always a furnace, or did it once hold gentler weather, a softer face? The clouds hide the answer, whispering only in storms we cannot survive. Earth, the only oasis of blue and green. When we look back from space, Earth shines unlike any other. Blue oceans, green forests, white clouds swirling like paint across a canvas. Among all the planets, it is the only one we know that holds life. This oasis was shaped not by chance alone, but by perfect balances stacked on top of one another. Earth rests in what scientists call the habitable zone, the Goldilocks distance from the sun. Not too hot, not too cold, just warm enough for liquid water. That water covers most of the planet, shaping weather, feeding rivers, and giving rise to everything we know. A thin atmosphere wraps us like a blanket, holding warmth, letting us breathe. It's almost fragile, this balance. A small shift, and Earth might have become another frozen Mars or another burning Venus. Yet somehow, conditions aligned. Volcanoes rose, oceans formed, life sparked, and here we are, speaking, listening, marveling at the same skies. From the outside, Earth is ordinary, just one more planet circling a star among billions, but from the inside, it is everything. Every song, every story, every dream has unfolded here. Earth is not just a planet, it is a home that holds us gently. How Earth's tilt gives us the seasons. The secret to spring blossoms, autumn leaves, and snowy winters is hidden in a simple tilt. Earth leans on its axis by 23.5 degrees. That small angle is enough to change the face of the planet as the year turns. Without it, we would have no seasons, only endless sameness. As Earth circles the sun, sometimes one hemisphere leans toward the light, sometimes away. When it tilts toward, days grow long, warmth stretches across fields, and summer blooms. When it tilts away, shadows lengthen. The air cools, and winter drapes the land in quiet. Between these shifts, spring and autumn soften the edges, blending one into the next. It's easy to take this rhythm for granted, but think of what it means. Every festival, every harvest, every migration of animals is tied to this lean. The tilt decides when rivers flood, when flowers open, when leaves fall. It is the planet's quiet metronome, keeping time for all living things. And yet the tilt isn't fixed forever. Over thousands of years it wobbles like a spinning top, slowing down. That wobble changes climates, reshapes history, even decides when ice ages come and go. A small, lean, shifting slowly, steering the fate of life itself. The moon's gentle pull on our oceans. Every wave that rises, every tide that falls is pulled by a quiet partner in the sky. The moon, though small compared to Earth, reaches across space with its gravity, tugging at oceans, lifting waters, letting them fall again. Twice each day, coastlines breathe in and out, as if the planet itself is moving with the rhythm of the moon. This pull is not only gentle, it is steady. It guided sailors long before compasses, it carved bays and estuaries, it shaped where people settled. Without it, our oceans would be calmer, but life itself might never have formed the way it did. Tides stir nutrients, mix waters, and create the conditions where fragile beginnings can flourish. And it isn't just water that moves. The solid Earth shifts too, rising by inches under the moon's gravity, though we barely notice. We live inside a world that breathes with the sky, even if our feet never feel it. Think of that next time you stand at the shore. That distant light in the night sky is not only beautiful, it is shaping the ground beneath you and the waves that touch your toes. Why the moon always shows one face. No matter where you stand on Earth, the moon greets you with the same side. The dark patches we call Maria, the bright highlands, the familiar craters, they never turn away. The moon is locked in what scientists call synchronous rotation. It spins once on its axis in the same time it takes to orbit Earth. This means half of it remains forever unseen to us, the far side, not truly dark, but hidden. For centuries, humans imagined mysteries there, from strange civilizations to untouched landscapes. Only when spacecraft circled it did we glimpse its other half, scarred and cratered far more than the face we know. The reason it's locked this way is gravity. Over ages, Earth tugged on the moon, slowing its spin until it matched its orbit. Now the balance is perfect, and the same face stares down at us eternally. It is like a companion who never quite turns their head, always watching, always present. This constancy makes the moon feel almost alive, a friend, a guardian, a silent witness to every human story. The same face that ancient people prayed to still looks at us tonight. Mars, the desert world with frozen secrets. Mars is a world of deserts, its surface rusted red by iron dust that coats everything. From afar it looks dry, barren, almost lifeless. But the deeper we look, the more secrets it reveals. At its poles, thick caps of ice glisten, frozen water mixed with carbon dioxide. Beneath its soil, traces of hidden water still rest, locked away in ancient layers. Long ago, Mars was not this dry. Rivers once carved valleys, lakes filled basins, and perhaps even oceans spread across its surface. Evidence of dried riverbeds and minerals that form only in water tells us this truth. To imagine Mars, then, is to picture a second Earth, young and blue before something changed. Today it is colder, thinner, stripped of much of its atmosphere. Winds whip dust across plains, storms swirl like ghosts, but the memory of water lingers everywhere. If life ever began beyond Earth, Mars is where it may have left its trace. Looking at Mars feels like staring into a mirror of Earth's past or a warning of its future. It carries both hope and caution, a reminder that worlds are fragile, even if they seem eternal. Evidence of water hiding beneath Martian soil. Beneath the deserts of Mars, radar scans have found echoes of something hidden, layers that reflect like liquid. These signals suggest underground reservoirs of salty water trapped beneath ice and rock. If true, they may be the last remnants of a planet once alive with rivers. Imagine that, right? A frozen desert on the surface, but below quiet pockets of water enduring for billions of years. Where there is water, the possibility of life always stirs. Even microbes, even the smallest spark, could change the way we think about our place in the universe. Scientists still debate this mystery. Some argue the signals might come from unusual clays or minerals, yet the possibility remains. Mars may still hold hidden seas, not in the open air, but in secret chambers underground. If we ever send explorers there, they may not find life walking across the sand, but beneath it. The thought makes Mars even more compelling. Its barren face is not the whole story. What lies below may rewrite what we know of life itself. A world that seems silent may be whispering, after all. The tallest mountain in the solar system. On Mars stands Olympus Mons, a volcano so massive it dwarfs every mountain on Earth. It rises 13 miles high, nearly 3 times the height of Everest, and spreads across an area the size of France. From its base, the slope is so gentle you could walk for days without realizing you are climbing. This giant formed because Mars lacks the moving tectonic plates that Earth has. On Earth, volcanoes shift as plates drift, but on Mars, the crust stayed still. Lava poured out in the same place for millions of years, piling higher and higher, until Olympus Mons touched the edge of the sky. Imagine standing there, looking out. The horizon would curve in strange ways, the scale almost too vast for the human mind. Shadows would stretch endlessly, and the crater at the summit could swallow entire cities. It is less a mountain and more a continent lifted skyward. To think this exists on a world so small and cold feels almost impossible, yet it reminds us of the solar system's wild creativity. Even in silence, even in frozen deserts, nature builds wonders that surpass imagination. Asteroid belt, a broken planet that never was. Between Mars and Jupiter lies a wide region filled with countless rocky fragments. It looks like chaos, but in truth, it is the quiet memory of a world that never formed. Gravity there was torn in 2 directions, pulled by the Sun, tugged by Jupiter, and so the pieces never became whole. Instead of one planet, we see thousands of asteroids drifting in an endless ring. Most are small, little more than boulders tumbling through space. Yet a few, like Vesta and Ceres, are hundreds of miles wide. They remind us of what might have been. The beginnings of a planet that stopped growing before it could be born. Each fragment holds clues about the early solar system, preserved like a fossil in stone. For centuries, people imagined the asteroid belt as a dense field where ships would weave between flying rock. But in reality, the objects are spread far apart, a desert of emptiness where loneliness outweighs collisions. Still they circle patiently, each locked in its orbit, each part of a grander harmony. And perhaps the strangest thought is this: the very fragments that never became a planet may one day help us reach new ones. Rich in metals and minerals, asteroids are the treasure chests of space, waiting quietly in the dark. Ceres, the dwarf world between giants. Among the fragments of the asteroid belt, one stands out. Ceres, the largest of them all. Once considered a planet when discovered in 1801, later reclassified as an asteroid, and finally named a dwarf planet, Ceres has lived many identities. Yet what matters most is the secret it carries: water frozen beneath its surface, and mysterious bright spots that glimmer like salt against dark ground. Those bright patches puzzled scientists for years. When spacecraft drew near, they revealed vast deposits of sodium carbonate, salts left behind by water that once welled up from underground. This means Ceres may have held, and perhaps still holds, subsurface reservoirs. In such places, the possibility of microbial life cannot be ruled out. Ceres orbits quietly, far from the headlines of larger worlds, but its story is profound. It bridges the gap between rocky planets and icy giants, reminding us that even in forgotten corners, mysteries hide. A lonely dwarf world, carrying oceans in silence, glowing faintly in the dark. Its quiet existence tells us something powerful. The solar system's wonders are not only in grand planets and blazing stars, but in small, overlooked bodies where whispers of life may linger. Jupiter, the protector and destroyer. Jupiter looms like a guardian at the edge of the inner solar system. Its mass is greater than all the other planets combined, a giant of gas wrapped in bands of storms. To Earth, Jupiter has always been both protector and threat. Its gravity swallows comets, redirects asteroids, shielding us from some impacts, yet it can also hurl others inward, sending them toward the inner worlds. Its sheer scale is hard to imagine. If Earth were a grape, Jupiter would be a watermelon beside it. Its storms could swallow our planet whole. Its magnetic field stretches millions of miles, trapping radiation in invisible belts. It is less a planet than a system unto itself, with moons orbiting like planets around a small sun. For billions of years, Jupiter has shaped the fate of Earth. Without it, the asteroid belt might have become a planet. Without it, comets may have struck Earth more often, perhaps ending life before it began. It is both shield and slingshot, friend and foe, a paradox written in clouds of gas. To gaze at Jupiter through a telescope is to feel small, yet also safe, as if this giant has been silently guarding us all along. The great red spot that outlives empires. On Jupiter's face lies a storm so vast it could fit 3 Earths inside. The great red spot, a swirling oval of crimson clouds, has raged for at least 350 years, perhaps longer. When it was first seen through early telescopes, empires rose and fell on Earth. The storm continued, unbothered by human time. It spins counterclockwise, winds reaching hundreds of miles per hour, colors shifting from brick red to pale salmon over decades. Sometimes it shrinks, sometimes it grows, yet it never vanishes. A storm without end. That idea alone unsettles the human mind, used to tempests that pass in hours or days. Scientists still debate why it lasts so long. Jupiter has no solid surface to slow it, no land to break its fury. Powered by heat rising from within the planet and fueled by the energy of surrounding jet streams, the great red spot endures, a scar that refuses to fade. If you were flying above it, the view would stretch endlessly. Cloud walls taller than mountains, lightning flashing like veins of fire, colors bleeding into one another. It is both terrifying and beautiful, the heartbeat of a world that knows no rest. Moons of Jupiter, more numerous than stars we can count. Jupiter is not alone. Around it, at least 95 moons orbit, with new ones still being discovered. From tiny captured rocks only a mile wide to giants larger than Mercury, its moons form a miniature solar system of their own. Each has a story, a surface, a rhythm. Together they make Jupiter less a planet and more a kingdom in space. The 4 largest, Io, Europa, Ganymede and Callisto, are called the Galilean moons, named for the man who first saw them through a telescope in 1610. Their discovery was proof that not everything in the heavens circled Earth, a truth that forever changed human understanding. Each of these moons is a world in itself, holding secrets as deep as planets. Io burns with volcanoes that never sleep. Europa hides oceans beneath ice. Ganymede carries a magnetic field, and Callisto bears scars of ancient impacts. Beyond them, dozens more tumble in strange orbits, some captured, some borne in place, all circling the giant. It is a reminder that our solar system is layered in complexity. Planets do not stand alone. They gather families, they shape companions, they weave tapestries of motion that stretch across centuries. Europa's ocean beneath an icy crust. Beneath the frozen shell of Europa lies a secret so extraordinary it could change everything we know about life. Scientists believe an ocean, twice the size of all Earth's seas, lies under its icy skin, warmed not by sunlight, but by the tidal flexing of Jupiter's gravity. The ice cracks and shifts, whispering of waters that move unseen below. On its surface, strange brown streaks stretch for miles, marks of salt and minerals rising through fractures. These are hints, like fingerprints, that something alive may stir beneath. Where there is liquid water, the possibility of life always follows. Microbes, perhaps, or something more. Europa is more than just a moon. It is an ocean world hidden in plain sight. The thought that life may exist so far from sunlight, living off chemical energy from deep vents, rewrites our idea of where life can be found. Maybe it doesn't need Earth-like skies at all. Imagine standing on that frozen plain, staring at cracks that stretch into darkness, knowing that beneath you lies an entire sea, unseen, untouched. It feels almost holy, a reminder that the universe guards secrets just beneath the surface. Ganymede, the moon larger than Mercury. Ganymede is not only Jupiter's moon, it is the largest moon in the entire solar system. Bigger than Mercury, it is a world in its own right, carrying mountains, valleys, and even a magnetic field of its own. No other moon can claim such power. If it orbited the Sun directly, we would call it a planet. Its surface tells two stories. Bright, icy regions crisscrossed by grooves and ridges speak of stretching and shifting over time. Darker patches, scarred by craters, reveal ancient ground that has seen billions of years. It is both young and old, alive and fossilized at once. Beneath the surface, scientists suspect another hidden ocean, locked under miles of ice. This makes Ganymede not just a frozen rock, but a potential cradle of water. Water beneath Europa, water beneath Ganymede. Suddenly the solar system feels less barren than we imagined. Standing there, you would see auroras dance across its thin atmosphere, glowing faintly as Jupiter's magnetic field collides with its own. It is a moon that refuses to be only a moon, claiming space as something greater. Saturn, the jewel wrapped in rings. Farther out lies Saturn, a planet so graceful it seems sculpted for beauty. Its golden atmosphere swirls with storms, but it is the rings that capture us. Vast, bright arcs of ice and dust stretching hundreds of thousands of miles, yet only a few dozen feet thick. They circle like a crown of light, delicate but vast. These rings are made of billions of particles, from grains of sand to mountains of ice, each caught in orbit, each moving with perfect rhythm. To look at them from a distance is to see serenity, but up close they are chaos. Collisions, fragments, endless motion held together in balance. No one knows for sure how old they are. Some believe they formed early, remnants of moons broken apart. Others suggest they are younger, perhaps only 100 million years old, a cosmic accident we are lucky to witness. One day they may fade, raining down into the planet they encircle, and yet for now, they are here, glowing in sunlight, reflecting beauty back into the dark. Saturn's rings remind us that space is not only about survival, but about art. Cosmic art drawn in ice, rings that could vanish in millions of years. Though Saturn's rings seem eternal, they are not. Slowly, gravity pulls their particles inward, and the planet's magnetic field drags them down in a ring rain that falls silently into the atmosphere. Over millions of years, the great arcs we admire may fade away, leaving only a bare giant behind. This knowledge gives the rings a fragile beauty. They are not forever. They are a moment in time. Imagine if humans had lived earlier or later. We might never have seen Saturn dressed in such glory. We live in the window of its splendor, a passing chapter in its story. Astronomers call this cosmic timing, where great events in the universe unfold across spans too vast for us, yet align briefly with our presence. The rings we gaze at tonight are already changing, already thinning. Every glance is a privilege, a glimpse before silence. It is a reminder that nothing in the cosmos is truly permanent. Even beauty, even grandeur, drifts away eventually. But while it lasts, Saturn wears its crown, and we are here to see it. Titan, a moon with rivers of methane. Among Saturn's many moons, Titan is the most haunting. Wrapped in a thick orange haze, it hides landscapes that feel strangely familiar. Rivers carve valleys, lakes spread across plains, and rain falls from clouds. But here, the liquid is not water. It is methane and ethane flowing in cycles just like water does on Earth. To walk there would be surreal. Seas ripple under a dim golden sky. Dunes stretch for miles, and the air is dense enough that with wings a human could almost fly. It is a moon that feels like a dream, alien yet eerily like home. Scientists believe Titan also hides a buried ocean of water beneath its icy crust. So above, methane seas sparkle, and below a salty ocean stirs. It is a world with tiers of liquid, both waiting with mysteries of their own. Could life exist in such a place? Not like ours, but strange, adapted, born from chemicals unfamiliar to us. Titan's duality makes it one of the most fascinating bodies in the solar system. It mirrors Earth in form but not in substance, reminding us that nature can write familiar patterns in alien ink. Enceladus, the moon that sprays water into space. Far smaller than Titan, Enceladus hides one of the solar system's most surprising secrets. At first glance, it seems like nothing more than a frozen ball gleaming white against the dark. But when spacecraft drew close, they saw plumes, jets of water ice erupting from cracks near its south pole, spraying into space like fountains. These geysers hint at something astonishing. Beneath the icy crust lies a global ocean warmed by the flexing gravity of Saturn. The cracks, called tiger stripes, act as vents, letting water escape into the void. Some of it falls back as snow, coating the moon in brilliant white. The rest drifts away, even adding to Saturn's rings. Inside that buried sea, chemical reactions may stir, the kind that on Earth give rise to life around deep-sea vents. Imagine tiny organisms thriving in a place no sunlight can reach, feeding off heat and minerals from below. If such life exists, Enceladus would become one of the most profound discoveries in history. For now, all we have are whispers, salts, organic molecules and water spraying from the cracks. But the moon keeps beckoning us back, as if daring us to look deeper, to pierce the ice and see what swims below. Uranus, the planet that rolls on its side. Among the giants, Uranus is the odd one out. Unlike every other planet, which spins upright or slightly tilted, Uranus lies almost completely on its side. Its axis is tilted by 98 degrees, meaning it rolls around the Sun like a ball instead of spinning like a top. Seasons there are unlike anything on Earth, lasting over 20 years each. This strange tilt may be the result of a colossal impact long ago, a collision so powerful it knocked the planet onto its side and left it rolling ever since. The result is a world both elegant and peculiar, with rings, moons, and clouds all orbiting in a sideways dance. Its blue-green color comes from methane gas in its atmosphere, which absorbs red light and lets blue filter through. But behind that calm shade lies mystery. Winds that reach hundreds of miles per hour, storms that flash silently in the deep, hidden layers that may even contain an ocean of water and ammonia under the ice. To see Uranus is to realize that not all planets follow the same rules. Some break the pattern, bending the script of creation, reminding us that the cosmos enjoys surprises. Why its seasons last decades? Because Uranus rolls on its side, its seasons are stretched to extremes. When one pole faces the Sun, it basks in constant daylight for over 20 years, while the opposite pole sinks into unbroken night. Imagine living in a place where summer is 2 decades long and winter is just as endless. As Uranus continues its slow orbit, 84 Earth years to circle the Sun once, the poles trade places. What was frozen darkness becomes blazing day, and what was day becomes endless night. The result is a planet of extremes, where time itself feels stretched, alien, heavy. If you stood on one of its moons, you would watch the strange light change slowly across years, the Sun creeping along the horizon, never rising high. It would feel less like seasons and more like ages, long passages of waiting and shifting skies. This rhythm reminds us that what feels normal on Earth is only one version of nature's patterns. Elsewhere, seasons can be centuries, days can be decades, and even sunlight can be stretched into silence. Neptune, the windy giant at the edge. Farther still, at the edge of the known giants, lies Neptune, a deep blue world, colder than Uranus but alive with storms and winds that defy belief. Here, winds scream at over 1,000 miles per hour, faster than the speed of sound on Earth. The calm color hides the most violent weather in the solar system. Discovered only in 1846, Neptune was the first planet found not by sight but by mathematics. Its pull on Uranus betrayed its presence. When telescopes turned, they confirmed what numbers had predicted, a hidden giant circling in darkness 30 times farther from the Sun than Earth. Despite its distance, Neptune is anything but quiet. Its great dark spot, like Jupiter's storm, appears and disappears, huge tempests rising from the depths. Methane clouds drift high above, giving it that rich sapphire hue, like a jewel against the black of space. Neptune reminds us that even at the solar system's edge, violence and energy still churn. Far from the warmth of the Sun, it spins with fury, a restless giant whispering that distance does not always mean stillness. The great dark spot that appears and vanishes. One of Neptune's most curious features is its great dark spot. When Voyager 2 flew past in 1989, it saw a vast storm, almost the size of Earth, spinning in the southern hemisphere, but when telescopes looked again years later, it was gone, vanished into the blue. And then, new dark spots appeared elsewhere. Unlike Jupiter's great red spot, which has raged for centuries, Neptune's storms seem more fleeting, forming and fading within decades. They are born from the planet's incredible winds, spinning into being, then dissolving back into the atmosphere. Each one is temporary, yet each one is vast. If you could stand above Neptune and watch, you would see storms drift, shrink, split, vanish, only to return again in another place. It is like watching clouds on Earth, except magnified to a scale beyond comprehension, a weather system that rewrites itself endlessly as if the planet enjoys painting and erasing across its own face. The Great Dark Spot reminds us that even giant storms are not eternal. They come, they go, they leave no permanent trace. And yet, in their brief fury, they show us the restless heart of a world we can barely glimpse. Triton, a moon that orbits backwards. Among Neptune's moons, Triton stands apart. It is large, almost as big as Earth's moon, but it moves in the wrong direction. While most moons orbit the same way their planet spins, Triton circles Neptune backwards, pulled against the flow. This strange dance hints at a violent past. Perhaps Triton was once a wandering object, captured by Neptune's gravity long ago. Captured moons are rare, and Triton bears the scars of its unusual history. Its surface is a frozen plain of nitrogen ice, cracked with strange ridges and dark streaks. Geysers spray from beneath, sending plumes into the thin atmosphere, showing that the moon is still alive with activity. Because it moves the wrong way, Triton is doomed. Slowly, over millions of years, its orbit will decay, and one day it may spiral closer to Neptune, tearing apart into rings before finally vanishing. Even now it circles quietly, holding its fate within the pull of gravity it cannot escape. To imagine standing there, looking up at Neptune looming across the sky, knowing your world is being pulled slowly to its end, is to feel both awe and melancholy. Triton is a reminder that even moons carry stories of capture, survival, and loss. The Kuiper Belt, a frozen frontier. Beyond Neptune lies a vast, dim frontier, the Kuiper Belt. Here, billions of icy bodies drift in orbits that stretch across hundreds of millions of miles. They are remnants of creation, left untouched, frozen since the earliest days of the solar system. Where the inner planets bustle with heat and storms, the Kuiper Belt is quiet, slow, and ancient. Among its icy members are dwarf planets, comets, and strange objects with eccentric paths. Each is a relic carrying the chemistry of the early sun. To study them is to look back in time, to hold the raw ingredients of planets in their untouched state. It is a place both lonely and crowded. Lonely because the vast distances mean each body is separated by millions of miles. Crowded because together they form a vast belt circling the sun like a ghostly shadow. The Kuiper Belt is the edge of the familiar, where sunlight weakens and darkness begins to win. For humanity, this region is still largely a mystery. Only a few spacecraft like New Horizons have crossed its threshold. What we've seen so far is enough to know. This is a library of frozen books, waiting patiently to be read. Pluto and the debate over what makes a planet. Pluto was once the 9th planet, taught in schools, loved for its small size and distant orbit. But in 2006, astronomers reclassified it as a dwarf planet, sparking debates that continue to this day. The reason lies in definition. Pluto shares its orbit with other Kuiper Belt objects, meaning it doesn't dominate its path the way true planets do. This decision upset many because Pluto had been part of our imagination for generations. It even has a heart-shaped region on its surface, captured by the New Horizons spacecraft in 2015, almost as if the planet itself was reaching out to remind us of its charm. Pluto is small, icy, and eccentric, with an orbit tilted compared to the others. Yet it has mountains of water ice, plains of nitrogen, and even hints of a thin atmosphere that freezes and falls as snow when it drifts farthest from the sun. It is not lifeless, it is dynamic, changing, alive in its own cold way. Perhaps the question of whether Pluto is a planet matters less than the wonder it inspires. Titles may shift, but the world itself remains what it is would be, a distant, heart-marked wanderer at the edge of our solar system. Charon, the moon that dances with Pluto. Orbiting Pluto is Charon, a moon so large compared to its planet that together they form a double system. Instead of Pluto alone pulling Charon, the two circle a common center of gravity that lies between them. They are dance partners, locked in a waltz across the edge of the solar system. Charon's surface is rugged, marked with canyons larger than the Grand Canyon, icy cliffs and mysterious dark stains at its poles. It is not just a passive companion, but a world of character carved by its own forces. To stand on Charon would be to see Pluto looming above, so close and large it would dominate the sky. Imagine the strange light, faint sunlight mixed with Pluto's glow, casting a pale world in soft shadows. Their bond is so close that both always keep the same face toward each other, forever locked in mutual gaze. Together, Pluto and Charon remind us that companionship exists even in the loneliest places. At the far reaches of the solar system, two frozen worlds turn together, bound in gravity, never letting go. Comets that carry ancient dust of creation. Comets are wanderers, icy bodies from the Kuiper Belt and beyond, falling inward toward the sun. As they approach, their frozen surfaces heat up, releasing gas and dust, forming glowing tails that stretch for millions of miles. These tails always point away from the sun, carried by solar winds like banners waving through the night sky. What makes comets magical is not only their beauty, but their age. They carry material unchanged since the birth of the solar system. Dust, gas, and frozen water from the original cloud that formed the sun and planets. To watch one streak across the sky is to see history burning before your eyes. Some believe comets delivered water and organic molecules to early Earth, seeding the planet with the ingredients for life. If true, then every ocean wave and every breath may trace its roots back to these wandering messengers. Their orbits are long and unpredictable. Some return every few decades, others take thousands of years. When they vanish into the dark, they leave us waiting, watching the sky for their return. They are reminders that the solar system is not static, but alive with visitors from the cold edges of time. The strange shape of Comet 67P. Not all comets look alike. When the Rosetta spacecraft arrived at Comet 67P in 2014, it found something no one expected. Instead of a simple sphere of ice, 67P looked like two lobes fused together, almost like a rubber duck drifting through space. Its surface was jagged, cliffs rising hundreds of meters, dust falling like snow in low gravity. As the sun warmed it, plumes of gas burst out, carrying dust into space. These jets reshaped the comet before our eyes, carving new features, filling the sky around Rosetta with glowing particles. Watching it was like watching a living creature breathe, shedding skin as it turned in the light. Its odd shape may be the result of two smaller bodies colliding gently billions of years ago, sticking together instead of breaking apart. The universe often builds through collisions, sometimes violent, sometimes tender, leaving behind strange hybrids like 67P. To see such a relic up close was to glimpse the very tools with which planets themselves were built. Comets remind us that beauty is not always neat or symmetrical. Sometimes it is jagged, broken, awkward, and still it holds the oldest secrets of creation. Meteoroids that become shooting stars. High above us, the smallest travelers fall through Earth's atmosphere every day. Tiny fragments of rock and dust called meteoroids race downward, burning as they meet the air. For us, they become shooting star brief streaks of light that cross the sky and vanish in seconds, something ancient transformed into something fleetingly beautiful. Most meteoroids are no larger than pebbles, yet the speed of their fall, tens of thousands of miles per hour, creates heat so intense they glow before they burn away. Every night, countless streaks pass unseen, a quiet rain of cosmic dust across the atmosphere. Occasionally, a larger one survives, reaching the ground as a meteorite. These pieces are gifts from space, carrying minerals, metals, and sometimes even complex molecules formed long before Earth itself. Holding one is like holding a fragment of the universe's memory in your hand. Shooting stars remind us that not every cosmic visitor is grand. Sometimes beauty arrives in small flashes, appearing without warning, gone before we can even finish a wish. Why meteor showers return every year. Certain nights each year, the sky blooms with dozens of meteors at once. These are meteor showers, and they are not random. Each one comes from Earth, passing through the dusty trails left behind by comets. As our planet sweeps through these cosmic streams, debris enters the atmosphere, sparking waves of shooting stars. The Perseids in August, the Geminids in December. These showers are traditions written not by people, but by the paths of comets. The dust trails remain for centuries, like invisible rivers through space, and Earth crosses them at the same point in its orbit every year. The result is a cosmic clock, reliable and beautiful. If you've ever lain on your back under the open sky during one of these nights, you know the feeling. Meteors streaking in every direction, so frequent you lose count. It feels less like chance and more like choreography, a reminder that we are moving through patterns far larger than ourselves. Meteor showers are gifts of rhythm, proof that even the smallest fragments of comets can create magic over and over again, year after year. The Oort cloud, the solar system's farthest whisper. Far beyond the planets, beyond even Pluto and the Kuiper belt, lies something we cannot yet see directly. The Oort cloud. It is thought to be a vast spherical shell of icy bodies, stretching trillions of miles from the Sun. Here, comets sleep in silence, orbiting so far away that a single trip around the Sun may take millions of years. We know the Oort cloud exists because some comets come from regions far beyond the Kuiper belt, their orbits impossibly long, their paths suggesting a distant reservoir of frozen objects. The cloud is the solar system's boundary, a place where the Sun's gravity weakens, blending into the gravity of other stars. Imagine a sphere so wide it takes light a year to cross, filled with icy fragments left from the birth of the solar system. Each one is a messenger waiting to be disturbed. By passing stars, by distant tides of the galaxy, before drifting inward as a long-period comet, lighting up our skies for the first time in ages. The Oort cloud may be the solar system's final whisper, a frontier that reminds us even our Sun has edges, where silence stretches into interstellar space. How far Voyager has traveled into the unknown. Launched in 1977, the Voyager spacecraft was sent to study the outer planets, but they kept going. Decades later, they are now the farthest human-made objects in existence, drifting beyond the influence of the planets into interstellar space. Their antennas still faintly whisper back to us signals that take more than 20 hours to reach Earth. Voyager has crossed the heliopause, the boundary where the solar wind meets the interstellar medium. It is the first of our creations to leave the protective bubble of the Sun, to touch the true space between the stars. What began as a mission of years has become a mission of centuries. On board is the golden record, a message for anyone or anything that might one day find it. Songs, greetings in dozens of languages, the sounds of rain, of birds, of human laughter. It is humanity's postcard to the cosmos, carried on a tiny craft through endless night. To think of Voyager now is to feel both pride and humility. A fragile machine built by human hands, crossing distances we can barely imagine. Out there, it drifts alone, yet it carries the voice of Earth with it forever. The golden records sent to the stars. Tucked aboard both Voyager spacecraft are golden phonograph records, tiny time capsules of humanity. Each record carries music, greetings in dozens of languages, images of our planet, and sounds of rain, waves, birds, even a baby's cry. It is a portrait of Earth, chosen with care, meant for strangers we may never meet. These records were built to last for billions of years. Encased in protective metal, floating in the cold vacuum, they will endure long after Earth itself has changed. Perhaps one day a distant civilization will find them and play them, hearing Beethoven, laughter, greetings from children in forgotten tongues. It is humbling to think of this, a fragile spacecraft drifting alone, carrying voices that may one day echo far from home. We may never know if anyone hears them, but the act of sending them matters. It shows that humanity wished not only to explore, but also to share. The golden records are reminders that we are storytellers, even across the stars. We could not resist leaving a trace of who we are, whispering into the cosmic silence. We were here. The heliosphere, our sun's protective bubble. Surrounding the solar system is an invisible bubble, stretched and shaped by the sun's constant outflow of particles. This bubble is called the heliosphere, and within it we are sheltered from much of the galaxy's harsher radiation. It is our cocoon, carried with the sun as it moves through the Milky Way. The heliosphere is vast, stretching far beyond Pluto, its boundaries shifting like the edge of a candle flame, flickering in the wind. Inside, solar particles dominate. Outside, the interstellar medium takes over. The meeting point is the heliopause. The frontier Voyager has crossed. Without the heliosphere, cosmic rays would strike Earth in far greater numbers, making life as we know it more difficult. It is a shield we rarely think about, yet it guards us constantly, woven from the sun's steady breath. To imagine this bubble is to picture the solar system as a ship, sailing inside its own invisible hull, drifting across a galactic ocean. We are passengers inside this vessel, carried by the sun's quiet wind, solar winds that whisper across planets. The sun does not shine silently, it also blows, releasing a constant stream of charged particles we call the solar wind. This wind races outward at nearly 1,000,000 miles per hour, touching every planet, shaping their atmospheres, sculpting tails on comets. It is the sun's breath, invisible yet everywhere. When the solar wind intensifies, it can stir storms in space, disturbing satellites, disrupting radio, even knocking out power grids on Earth. To us, it may seem distant, but our technology is woven into its rhythm, vulnerable to its moods. Yet the solar wind is not only threat, it is also beauty. When it collides with Earth's magnetic shield, it creates the auroras, painting the skies with ribbons of green, red, and violet. The same breath that can disturb our machines gives us one of nature's greatest displays. Across the solar system, each planet receives the wind differently. Some deflect it with magnetic fields, some are stripped bare by it, some wear it like a cloak. It is a reminder that the sun does not just light the worlds, it touches them constantly, like a parent brushing against each child, the magnetic shield that guards Earth. Earth is not defenseless against the solar wind. Deep within its core, molten iron swirls, generating a magnetic field that stretches far into space. This magnetosphere deflects most of the solar particles, steering them away, protecting the air we breathe and the life we know. Without it, our atmosphere would have been stripped away long ago. Mars, lacking such a shield, is a cautionary tale. Its once thicker atmosphere was slowly blown into space, leaving behind a dry, cold desert. Earth, by contrast, has held its oceans and skies, sheltered by an invisible guard we rarely notice. The magnetosphere is not static. It bends and flexes as solar winds press against it, sometimes snapping in bursts that send energy rushing toward the poles. These moments create storms in our atmosphere, storms that are invisible to most, yet felt in our technology and our skies. It is strange to think that something unseen protects us every day. We live under its constant care, rarely aware that without it, Earth might be as barren as Mars. How auroras paint the polar skies. When solar particles slip past Earth's magnetic defenses, they are guided toward the poles, where they collide with the atmosphere. Atoms of oxygen and nitrogen light up, glowing in greens, reds, purples. This is the aurora, the sky itself turned into a canvas of shifting light. For those who have stood beneath it, the aurora feels otherworldly. Curtains of light ripple across the horizon, twisting, fading, returning again. It is silent, yet it feels alive, as though the earth is breathing in color. People have told stories of spirits, dragons, or messages from the heavens when they saw these lights. Each color tells a story. Green from oxygen at lower altitudes, red from oxygen higher up, purple and blue from nitrogen. The sky becomes a laboratory of beauty, each collision of particles an artist's brushstroke across the dark. Auroras remind us of our connection to the sun. Even when it is far beyond the horizon, its breath paints our skies. They are the most visible proof that space is not empty but alive, interacting with us in ways both dangerous and breathtaking. Space weather that can disrupt power on Earth. When storms brew on the sun, their effects can reach us in ways both beautiful and dangerous. Solar flares and coronal mass ejections release massive bursts of energy, sending waves of charged particles into space. When these waves strike Earth, they disturb our magnetic shield, shaking it like a bell. This is what scientists call space weather. Most days its effects are subtle, invisible to our eyes, but sometimes the storm is strong enough to disrupt satellites, scramble radio signals, or even knock out power grids. In 1989, a solar storm caused blackouts in Canada, leaving millions without electricity. A reminder that the sun, though distant, still rules our lives. Yet space weather is also a source of wonder. The same storms that can disturb our machines also light up the skies with auroras, shimmering curtains of color that remind us of our bond with the sun. Danger and beauty arriving hand in hand. Space weather shows us how fragile our technology is, how dependent we are on invisible forces we cannot control. But it also reminds us that nature's reach is vast, stretching from the sun's core to the lights in our homes. The subtle gravitational dance of planets. The planets do not move alone. They tug on one another, each orbit shifted slightly by the others. This gravitational dance is delicate, invisible to the eye, but it shapes the solar system over millions of years. Jupiter, the giant, pulls hardest. Its influence shifts the orbits of asteroids, even protecting Earth by deflecting some objects. Saturn, too, adds its weight, creating resonances, rhythms where orbits align in repeating patterns. These small tugs add up, sculpting the long-term harmony of the planets. Even Earth's orbit is not untouched. Over ages, these gravitational nudges alter our distance from the sun just enough to bring ice ages and warm periods, weaving climate into cosmic rhythm. We live inside a system that is not static, but constantly moving to an unseen beat. The solar system is not clockwork, not perfect, but more like a symphony. Instruments drifting, aligning, sometimes clashing, always creating something greater than the sum of its parts. Each planet, each moon, each rock plays its quiet role in the music. How Jupiter shaped Earth's chance at life. Without Jupiter, Earth might not exist as it does today. The giant planet's gravity swept the early solar system, pulling away debris, preventing endless collisions and creating a safer region for smaller worlds like Earth to form. Some scientists believe Jupiter acted as a shield, sparing Earth from bombardments that could have erased life before it began. But Jupiter also played a role in delivery. Comets and asteroids nudged by its pull may have carried water and organic molecules to Earth, seeding the young planet with the ingredients of life. In this way, Jupiter was both protector and provider, guardian and messenger in one. Its position, its mass, its orbit, and all these things aligned to shape Earth's history. If Jupiter had been elsewhere or smaller or absent, our story might have been very different. It reminds us that life is not only shaped by Earth itself, but by the giants that circle nearby. Looking at Jupiter now, glowing through a telescope, it's humbling to realize it may have quietly chosen our fate, allowing us to be here tonight, telling this story, the rare alignment of planets in the sky. Every so often the planets line up in the night sky, strung together like beads across the horizon. These alignments are rare, sometimes centuries apart, and they have fascinated people since ancient times. To see multiple planets shining in a single arc feels like watching the solar system itself unveil its hidden geometry. Though alignments have no mystical power, they carry emotional weight. Ancient astronomers saw them as omens. Kings watched them for signs. Poets wrote of their beauty. Even today, when telescopes explain the science, standing beneath a planetary alignment still stirs awe. The alignments happen because each planet orbits the Sun at a different speed. Only occasionally do their paths bring them into the same part of the sky from our view on Earth. When they do, the effect is striking. Bright worlds gathered in silent congregation. Such moments remind us that the solar system is not random chaos, but structured motion, full of repeating patterns. It is as if, every once in a while, the planets pause to stand together before drifting back into their solitary paths. Planetary resonance, music in orbits. If you listen closely to the solar system, not with ears, but with math, you find that the planets move in resonance, like music. Resonance happens when orbits repeat in simple ratios. For example, Pluto orbits the Sun twice for every 3 orbits of Neptune. They never collide, but their rhythm keeps them safe, locked in harmony. This hidden music extends throughout the system. Jupiter's moons Io, Europa, and Ganymede are locked in a 1-2-4 resonance, their orbits timed like notes in a song. Each pull strengthens the rhythm, creating stability that lasts for billions of years. The solar system is less a machine than a symphony, notes striking chords in space. Resonance is subtle but powerful. It can protect, preventing collisions, but it can also destroy, pulling objects into unstable paths, sending them spiraling away. It is both harmony and discord, beauty and danger. To think of the solar system this way is to imagine that every orbit is part of a greater score. We may not hear it, but the music plays on, written in gravity, endless and unseen.